Assalamu alaikum. My name is Mia Abdul Wahad Shahid, roll number 2331. This is the assignment number 1 for digital image processing. Today we'll be looking at 6 of our image manipulation MATLAB algorithm codes in MATLAB. These are linear intensity scaling, negative image, logarithmic transformation, bit plane slicing, power law transformation, and contrast stretching. First, let's run the code of linear intensity scaling. The provided MATLAB code performs linear intensity scaling on an input image, in this case used from the website provided in the description. This is the grayscale image of penguins taken from the website. As you can see that the code reads the image and converts it to grayscale if it's an RGB format, and then scales the intensity levels linearly to add the desired range. So uh, as you can see the this is where the linear intensity scaling is performed, and the conversion into grayscale is done over here. So I have used the subplot commands to display the original and scaled images. Rest of the code is very much self-explanatory. Let's look at our second code, negative image manipulating. So the provided MATLAB code reads an image, calculates its negative and displays both the original and negative image side by side. The code is pretty much generic, works on the algorithm provided in the book. So what it does, it simply converts the image into negative by inverting all the image parameters. Let's talk about code number 3, logarithmic transformation. So the provided MATLAB codes applies transformation to an image and displays both the original and transformed image side by side. Let's let's break down our code. So um, the code reads an image and first converts double precision using some mathematical operations discussed over here, and then a logarithmic transformation is applied on the image using log over here. As you can see, I have highlighted where my mouse cursor. Over here in the image you can see the logarithmic image process done on the original image. The normalized final image is converted back into unit 8 data type for display. So subsequent subplots are used to ensure the function points correctly. Let's talk about bit plane slicing algorithm and its code. So the provided MATLAB code performs bit plane slicing of an image, extracting and displaying each bit plane as a binary image. As you can see, this was our original image. This was our original image over here, the grayscale one. These are the bit division of the same image: the bit 0 division, bit 1 division, bit 2 division, bit 3 division, bit 4 division. They essentially overlap on each other to make the whole image. So let's talk about the code. The code reads an image and converts it into grayscale. Then The number of bit is set to 8, assuming the image is an 8-bit grayscale image. An array is initialized over here uh, to store the bit planes extracted from the image plane. The code uses a loop to perform bit plane slicing over here. So the figure is created to display each bit plane in a binary image using the appropriate function. Subplots are used to organize the display, and titles indicate the corresponding bit plane. The rest of the code is used to display each bit plane. Let's talk about our next code, which is power law transformation. Let's run the code. So the provided MATLAB code applies a power law transformation to the image. What it does, it reads the image and converts it to double precision using double original image. As you can see here, I've used my cursor to indicate the specific portion of the code. The power law transformation is applied in each pixel using the formula original image divided by 255 raised to the power gamma over here. So the results that come after the implementation of power law algorithm is shown in the figure 2. So our last code is contrast stretching. Let's run it. So what it does, it takes an grayscale original image and performs the desired minimum and maximum values for stretch ranged, which are specified by the user. So then it stretches the original image by some value. I have given the value to 55 for the minimum interval and the maximum interval. So what it does actually, contrast stretching enhances the contrast of an image by linearly scaling the intensity values to desired range. As I have discussed over here, we can change the value as far as we can. Let's change it to 55 in order to see the effect of our code. So our code is given the low value of our code. Let's try 155 in order to see what it actually does. So for some reason 255 is the only value that it will take.